Hello everyone, welcome back to the channel. Today we're diving into the world of geospatial analysis with Python and QGIS. First, we'll start by introducing the QGIS Python console and explaining which version of Python we're using. Next, we'll take a quick look at the QGIS Developer Cookbook, which will become our go-to reference for scripting inside QGIS. Then, we'll dive into the main part of the tutorial, building a Python script that takes raw Sentinel-2 satellite data and automatically creates an RGB composite image. So grab your coffee, open up QGIS, and let's get started with some geospatial scripting. Instead of manually loading and stealing each bond, our script will handle everything from reading the rasters to merging them into a single, ready-to-use RGB composite image in your QGIS project. Sentinel-2 provides high-resolution optical imagery with keybands like red, green and blue, available at 10-meter resolution. The multispectral instrument uses push-broom imagery technology, scanning the surface line by line as the satellite moves, with each detector tuned to a specific wavelength range. This gives us detailed multiband image that we can combine or analyze depending on our goal. So the MSI sensor on Sentinel-2 captures light in 13 distinct spectral bands, from visible light to near and short infrared. So, spectral bands are a specific portion of the electromagnetic spectrum that satellite sensors capture separately. Each band records reflectance values at a given wavelength, revealing different information about the Earth's surface. For example, the red, the green and the blue bands together form the RGB composite image, what we perceive as a natural color. So, let's investigate it into a data hub. Before we write any code, let's grab a real dataset. We will download Sentinel-2 imagery from the Copernicus dataspace. You can launch the Copernicus browser here. So you can log in or go into anonymously. So I will log in into the platform with my email account. Okay, great, welcome to Copernicus browser. So now we are going to select the dataset we want for this case today. So the first step is to define the area of interest. So I go near Arles in France, I draw a rectangular area and I configure the Sentinel-2 dashboard. So we will set a single date. No, I will search for some specific products. So with these multispectral instruments with the Sentinel-2 L2E, and we will find some data sets. So here we see that there are many results available. So basically, I will choose this dataset. So I click on it. And here you can download the product. Here is a window that shows the attributes. So for example, the summary of the product, we see the instrument, we see the dates of the product, the location of the product, and many metadata that are really important. So once the dataset is downloaded, you go cut it from your downloads and you put it into folder of your environment. You extract. Okay, so here now it's extracted. You can see that in the granule, the image data, you can see 3 resolutions. We will go into the 10-meter resolution, and here you can see the RGB bands of Sentinel-2 at 10 meters resolution. We will work with those 3 Sentinel-2 bands. So the next step is to open QGIS, and we will discover the Python's console into QGIS. So let's start by opening the Python console. So you go to Plugin, Python console. So the full code is available on my GitHub here. So here is the Python script that I wrote. So you copy and paste this script into your Python console. So you can move the window here to see better. Okay. If you'd like more details, feel free to let me know in the comments. I will reply with pleasure. So here, the first step, or preliminary step, is to import the Python libraries. Import the required libraries that we use in this script, in this Python scripts. So this module allows us to search, match, and manipulate text using patterns. So once those libraries are imported, you can define the path to the single band TIFF. Well, actually, there are GP2 file. So the first step is to define the path of your single band. So the red, the green, and the blue bands that are located here in my computer. So basically, that's the path of the file I've just downloaded. And after that, we can use the RE module to search and to define the date match. So the date match will search for this date and extract it as a string. This allows us to extract dynamically our raster name with, for example, the date. So the output raster will contain this date on each new execution of the script. So this was the second step of our script. The step 3 will be to define the output path for the final raster file with the date in the name. So here is the name of my raster, and we will merge it with the raster date, and the output file will be in TIFF format. The fourth step is to check if the raster layer are valid with this function, or a QGIS raster layer. It's better to do this before processing. If the process is valid, we can merge the band into a single RGB Composite Raster. The input bands are the bands we just defined it, so it will basically read those bands. The resolution is in 10 meters. The bands are separate, and the output will be the output raster. We will use the GDAL merge processing. It will print this text if the process is complete successfully, and it will basically load the create composite raster into QGIS once the process is done. The scripts also include error handling in case something goes wrong. That's it. So if you need more detail, feel free to let me know in the comments, and we will run this process. Okay, great. So we see that the process has been successfully done. If we go to our output layer, we see that our raster has been successfully downloaded. And now we can see the beautiful RGB composite image that we've just downloaded into the Copernicus Data Hub. So you can copy and paste this script if you want to automate this process. In the next Python QGIS tutorials, we'll take things further by learning how to automatically analyze a raster. We will dive into extracting automated statistics from the raster using the Python console.